My name is Umachandar. I'm a program manager in the SQL Server team. So I worked on the SQL Server R services, and now we're integrating Python. And today I'll share with you what we did for 2017 and also like 2016 stuff. Quick show of hands. How many of you know R or use R? OK. What about Python? Oh, actually more like, so it's probably like, I don't know, 30 people versus 20 or something like that. OK. And how many of you tried SQL Server R services in 2016? OK, handful, like about 10. OK, cool. OK, so this is the agenda I have for today. I'm going to give a quick intro on what is machine learning, and also our perspective of how you operationalize that with SQL Server, right? I have some links to some sessions later, so you can actually go and attend that if you're interested in knowing more about it. And then we'll look at SQL Server machine learning services, what it is, and we'll do some quick demo and some basic functionality. And then I have a set of slides on what we learned from customers today. And I picked a few scenarios, so we'll take a look at that. And that's all I have for today. OK, cool. So intro. So at a high level, this is basically predicting some new property, right, based on some historical data. So that's really what it is, right? So you look at some sample data, training data, historical data, whatever you want to call it. And the model infers the properties and attributes which you want to learn from the data. And then you use that to predict, right? So it's a high level. It's really, that's what it is. So you try to predict some information for new data based on historical information. So what are some examples, right? So this is one of the common examples. How do you predict sales of a particular store in a region, right? So this is something many department stores do that, right? And so here it's like a time series data. So they'll probably build a model which uses, I don't know, last few years or last few months, whatever granularity. And then as the new data comes, you want to basically say how a sales is going to do in a particular store, right? So that's an example. And then another example is you have a credit card transaction coming into the database and your system, and how do you want to say if it's a fraud or not, like a probability, right? So this applies in other areas, like for example, you have an insurance company which is taking like new applications, and you want to assign like a risk score for those applications, right? So based on, say, the credit report and previous payment history and stuff like that, they can actually say, hey, this might be a risky customer, so we'll probably not give him the loan or something. Right? And then the other one, this is common. So we are working with a customer who's trying to do this. It was also shown in Ignite like last year, I think, like demo. So same scenario. So you have a bunch of loans, and you want to say which one has a probability of getting a default, right? So this is something predicting a future, right? This is also very common. I have a demo which I'll show you later. So this is basically like, how do you say if a particular review or tweet or whatever it is a good one, negative one, or it's neutral, like sentiment, right? So that's so this is basically looking at text data and then getting information from that. So this is also common. This, I believe, yesterday in Joseph's keynote, you saw that, right? Like where you have a image, it's a T-shirt, and then it goes, looks at features from there, and then it tries to match stuff, right? So that is that one. This is like classification. So this is also common. Like, for example, you have a lot of transaction data and customer information, and you want to find groups of customers, right? Like based on, say, certain patterns or how they buy products, or how they abuse your system, like, for example, buy products and keep returning, or like, I mean, do that kind of stuff. So there are algorithms which can actually look at the data and then find these groups, right? So you don't have to go define the thing. It can actually infer the pattern from the data. So that's pretty much like, these are the examples. I mean, you can see like some of these algorithms, you can use it to solve like linear regression, for example, can be used in different places, right? Decision tree can be used in same way, different applications. And then what are the popular ML technologies? I mean, clearly, I mean, like R and Python. I mean, you saw a lot of people here use both R and Python. And basically, our investment is to get SQL Server to run R and Python in the database, right? And Microsoft also has R and Python investments in the cloud and so on. So yeah, so this is what we're going to focus on. Okay, so what is operationalization, right? So for us, it's basically like building an app. So it's taking this model, taking these predictions, putting it in your database system, right? So that means any application which can connect to the database can use this intelligent information. Right? So that's really what this is. So let's look at how people do today, right? Like we had last year a bunch of customers who were doing this, and then once we had the database integration, they could actually make some changes to their process, which made it simpler, right? So let's quickly look at what you would do. Right? Again, this is focused on how somebody would use this with SQL Server. Okay, so the previous slide we had the context of looking at sample data, right? So that's really what this training is. So you have database, I mean, with some bunch of historical information, and you do some training. So this is the process which looks at the data and then produces some object, right? And we'll call that typically like model, right? So think of it as like a list, or I don't know, in the SQL Server terms, like table with bunch of columns and attributes. That's what it is. So and then like you store that back in the database. I mean, actually we found that many customers don't do that. They're actually putting it in some file somewhere. It's not even version controlled and so on. But assuming, say, you do that, like so now it's sitting in the database. Now you have applications which are actually doing many transactions in the database, right? It could be, I don't know, just a OLTP kind of thing, or it could be like a reporting application. So that's what happens. So now how do you incorporate the predictions for new data, right? So that's the part which we call scoring, right? So that takes the model and then the new data and then says, okay, what is the outcome? So like in the fraud case, it will give a probability saying this transaction is probably like 90% like fraud or something, right? In other cases, it might predict like a class of the customers, right? Like, are they going to buy this product or not? So the input to that is the new data, right? And then it's going to take the model also from the database. And then you take those predictions and you incorporate it into the application. So the application here could be a website, it could be a Power BI dashboard, I don't know, anything, right? So now that's consuming the predictions and giving it to the end user, right? So that could be in the form of some, I don't know, email or whatever, or just an indication in the website and so on. So now what is the problem with this picture is, so we find that to do the model training, folks have to spin up a different server, right? So we typically call it an analytics server. So if you're using R, then you spin up another server where you're running your R scripts. So now two things is happening, like that's a different machine, it's not your SQL Server machine. So you'll have to move data from your SQL to that box, right? So that's one of the problems in terms of like how fast you can operationalize this stuff, right? And then the whole investment of managing the analytics server and the environment and so on. I mean, and there is an aspect of concurrency which is actually makes it even more harder, right? Like imagine you have a big data warehouse and you want to actually build hundreds of models, right? Or you have data scientists working on your data warehouse, and each one is building a different model. So how do you allocate resources across these different folks, right? So that's one problem which is hard to do there. And then the scoring part. So here this becomes actually very tricky. So we found like one of our customers, so they actually took the model, right? Like once they have the model, then they re-implemented the scoring part in Java, right? Because their app is in Java, and then they didn't really want to call into R from Java. And, I mean, it's not really straightforward. You have to put like some web service front end there or do some other means. So they actually did that, and that's what we. So what typically happens is you either have to spin up a separate service, or most people like transform the thing and put it in some other application code, right? So now you'll have these two pieces you have to manage, and these are actually different, and it's not. So now you have this app which has to like talk to SQL Server, and then it has to also talk to this other things, right? So that's the complex thing. So now what can we do? Okay, the database didn't become bigger, but so you have the same SQL Server database. So now one thing you can do is you can take the model training process. If it's written in R and Python, you can put it inside the database, right? So now it's just a stored procedure in there, and it's integrated with SQL Server, right? I'll talk about what it means. And then same way with the scoring. So you have a script which is using R and Python, and it's doing scoring. You can just put it in the database. The model is there in the database. The data lives in the database. And you don't need to do this data movement, right? And the other advantage is now you can manage all of this as one box, right? Your SQL Server resource, right? So how does it simplify the application? So same thing, the app is doing a whole bunch of transactions, and now the new data comes, and your predictions is just another stored procedure call or a query in the database, right? So there is no like as part of the new data, like you have to insert the data first, send the data to some other service, and get the score, or do that round trip kind of thing. So that's really what it is. So what are the advantages, right? So one thing we see is like the ease of operationalization, right? It's a hard word, like we have trouble sometimes pronouncing it, but that's what we're calling it, right? So that means you integrate it into your SQL workflow, your ETL process, whatever, right? So imagine you have a ETL job which is importing new data, and then as part of that, you want to maybe generate predictions and store it in the database. Now you can just have a SQL agent job which is calling a stored procedure, and it's doing the training and putting the data in a table, right? So that's one way to integrate. Performance. I'll talk about it when I do some of the demo. So, but the thing is, like, so SQL, as you know, has many capabilities, right? Like you can have in-memory column store, you can have a disk-based column store, you can have in-memory table, we have parallel queries. So now this feature integrates with all of that in terms of the data part, right? So that means you can have a query which is running in a SQL Server, and at the same time, it can be sending the data in parallel to a bunch of R processes or Python processes and do the training, right? I'll show you one example there. And then the other aspect, which is actually very important, is the HA-RG part, right? I talked about like data warehouse, like where you have data scientists using the data warehouse for training. So now with the previous picture, doing resource governance and HA on that is very hard, right? Like if you have your own analytics server, then you have to essentially build your own thing, right? So now here we are saying, hey, SQL has HA, many HA capabilities, right? So if you have always on cluster, for example, you can run the R scripts on the secondary, right? And you can spin up new nodes if you want, or you can even run it on the primary. And if there is a failure, your workload just moves, right? So you get that integration aspect. And then the resource governance aspect is also very important. Like you can control resources for the external processes, just like how you would do for SQL, right? So that gives DBA like good control as to like, hey, how do I want to split the resources on the SQL Server machine, and with always on, you can actually put it on a different machine also, right? So these are some of the advantages of this integration, and that's something we see like customers leverage and use, right? Cool. So let's look at what is it. 6. Is it coming? Okay. Oh, that's Mount St. Helens. Okay. Can you see the font in the back? Like I think it should be fine, right? Okay. Bigger? Oh, okay. make it bigger. Where does it zoom in? This RStudio does some magic. Is it fine now? Can go bigger. Okay, so what I have here is RStudio. So this is again one of the popular IDE used for developing R scripts. I mean, it's open source. So we talked about this whole data movement part, right? Like, so our thing is like you push the compute over to the SQL Server machine, right? Because the data is there, it's in a secure place, and you can do the computation local to the data, right? So that's our goal here. And actually, I should have shown the other script. This is for later. So what do we want to do, right? Like, so one of the things Microsoft provides as part of the R server or the Python integration is a set of packages which allow you to push compute over to SQL Server as opposed to moving the data and doing the compute, right? So I'll show you how it looks here. I mean, it will look almost like your ODBC, connection, like typical client-server thing, right? Like, how do you do? Like, you define a connection string to your database, and then you run a bunch of commands. So same thing. So you have this object called SQL Server data, right? Rx SQL Server data. So this represents the data living in SQL Server, essentially. So you can give it a query or a table, and then a connection string, and that's the information it needs. And then the other thing you can do is you can say, hey, I actually want to set the compute context to the SQL Server machine. So that means I want all of these Rx functions to run on the SQL Server box, right? So that's what we'll do here. And then later you can run whatever function you want. Like this is, I'll show later. This is the review one. So this algorithm, it's running Rx, it's called Rx for rapid execution. So all these Rx stuff allow you to remote the call. I mean, it's transparent to the user itself. They don't actually know that. They're just running a R function. So this function now, since you've set the compute context, it's going to run, send the function call over to SQL Server, and then just get the results back. And it will be just a blob, right? So we can quickly run this. I mean, in this case, I'm running locally here. I don't want to connect to the VM because I had like trouble earlier. So this is going to run, and then you can actually see SQL here. I mean, this BXL server, it's actually run. You see the account there, SQL 1702. So it's actually running here locally on my machine, but yeah. So now it's going to send the result back. It takes about a minute, I think. Yeah. And then same way you can do the reverse. So now you have the data. You can actually do this. Right. So this says like what is the type of object and so on, right? So now this scenario enables like somebody on this laptop, I can actually connect to my other lab server and then run it on this one is like a 1 gig scale. I can run it on a 1 terabyte scale, same command, right? And that's not actually moving the data over to my machine. So that's really what I wanted to show here. Okay. And then, so here now how do you do the same thing in SQL Server is, so we added a system stored procedure which basically takes an R script and then some SQL queries. And you can send data to it, get data back. You can send parameters, get parameters back. And that's the basic interface, right? I mean, this example just shows like how to call an R script and then get some information out. So this is going to print some information like the version of the R runtime, right? The first row. What is the version of the Microsoft R server component, and then the directory, like where it's running from, and so on, right? Just to. So this is a good example of like how do you take some data from R, change it into a a result set, and then return it to SQL Server, right? So the equivalent, like just like table in R, it's this object, this data frame, right? That's really what it is. You can think of it as a table with columns and values in there. So that's what we did there. Okay, now same thing, like for example, you want to find out like what packages are installed, right? What are packages? Package in R is essentially the library, so that is the extensibility mechanism in R. And I mean, it has like, I don't know, 100 packages or something installed. So you can find out like what versions are there and so on. Now, same thing you can do with Python. I mean, the code looks a bit different. So in Python doesn't have a native data frame object, but the most common one people use is like the pandas data frame. And we actually ship a version of the Anaconda distribution with SQL Server when you install it. So let's see what it returns, right? So it's going to say 3.5 something, and then where is the Python home, what is the R server version, and so on, and some libpath, right? Same way, you can go find what packages are installed in Python. So pip is the Python package manager. So that's what you can use to install new packages, or you can use Conda also. So same thing, it runs the command, and then you can get the thing. Okay, so that's quick intro on what the machine learning services is. Okay, so now how do you, I don't know how, I mean, I had a bunch of folks, like 10 people you say I used it, right? So this is how the setup looks in R services. So if you're not familiar, I mean, you just need to check that box there, and that's SQL Server R services. And with CTP2, it's now called machine learning services. So it's the same feature, but it's like different level. And then there you get a choice of, hey, I want to use R or Python, right? That's pretty much it. And then the other information, I mean, resource which is of use, I have the link later, is like you should download these reports which are there in GitHub. So this allows you to look at the configuration of the system or do the configuration. It allows you to look at packages, I mean, and also like currently running R scripts and so on, right? So that's something to keep in mind. Okay, so we saw the code execution, all this, right? Like, so now what is the thing which allows you to run this in SQL Server, right? I'll quickly describe that just for you to get an idea of what it is. So we actually built a new framework in the engine. We call it like extensibility framework, which allows you to run or host external runtimes in a secure manner on the SQL Server box, right? So for us, like in SQL Server in general, like the order of importance for us is security, perf, back compat, right? Like, I mean, those trump pretty much everything, right? So that was the biggest challenge for us, like how do you run these things on the SQL Server box, and if something happens there, I mean, you can't really compromise a query running in SQL Server, right? So that means even if there are two users running queries like or R scripts, you actually don't want them to look at each other's data. So that's also important because SQL Server itself will have, row-level security and access control and so on. So now how do you make that work with R, right? And then resource governance, I touched on this. So we now have a new object called external resource pool. From SSMS, if you're familiar with resource governor, you'll see this additional object there. So this allows you to define, CPU memory usage for the R scripts or Python scripts, and then including like affinity on like very big boxes. So this allows the DBA to very granularly control what happens on the server box, right? And then this is another one, the integration with the whole query execution. I mean, that's where the power is, right? Like, I mean, you can run through massive amounts of data in SQL Server very efficiently. So now how do you move some of this data over to the R script for execution and get the results back, right? So that was a big investment for us. So then on top of that, we also added certain execution modes like streaming. So this is very common, like for prediction scenarios, right? Say you want to score like 1 billion rows, right? But then you don't want to load all the 1 billion rows in memory. So by default, like R and Python, I mean, they're not like SQL Server, right? Like there's nothing like memory allocation being, buffered or like deferred and so on. If they're not able to allocate a memory, I mean, they're just going to fail, right? So in that kind of scenario, if you're using just some R function which wants to do some prediction, you can use a streaming mode which allows SQL Server to actually send rows in chunks. So this is a way to actually run even like scoring on 1 billion rows. I can run it on my laptop, right? It'll run slow, but it'll run, right? And then the other place where we invested in 2017 is the batch mode execution. So how many of you are familiar with column store and batch mode? Wow, one, okay. Okay, column store has, so typically in database systems, right, like if you look at the query, like how the query executes, it's all a per row kind of thing, right? So you scan a table, you return the row to the next operator. It could be like a sum, for example, and it's going to add the value, and then it's going to say, hey, give me the next row, and it's going to add the value, and so on, right? So with column store, we have a special mode where it executes, each of these operators runs in batches of rows. So that means the overhead of calling into every operator is reduced. And then the other advantage is like this integrates well with how caches are there in a lot of these new CPU architectures. So that means everything, these 100 rows kind of fit in the cache very nicely, and it can actually go through those fast. So here what we did was our operator can now run in batch mode. So that means you can send these rows very efficiently over to R and then do the computation, right? So we see about like 20 to 40% perf difference between say 2016 to 2017 for many scoring scenarios. And then the last one, this is something which is also important, is like there are scenarios where from the R scripts or your Python script, you want to actually say write data back to SQL Server, right? Or write even to multiple tables. So the current stored procedure mechanism, you can only return like one result set, and you can actually only insert into one table in SQL Server, right? So we basically extended how integrated auth works so that from the script, you can do a loopback connection, and it will impersonate the original user. So this is a way to run this securely. And yeah, so that's pretty much it. Okay, so what are some of the things we learned from customers, right? Like, so I mean, customers meaning like both internal, external customers. Internally, Microsoft has like a big, data science community. So I have some slide on like what are the things I saw and like how you should actually be looking at it, right? Okay, so I have this classification as don't and do's. So first one is like, hey, don't run your R or Python script as is, right? So this integration is not about that, right? This is about a data integration with, R or Python. I mean, you can cut and paste any Python script in there and it will work. But then that's not how you want to leverage this, right? So this is about like, hey, putting the data, processing aspects and data crunching of SQL Server and using that for a lot of the stuff, and then use R and Python for what it is, right? So this is something I saw like quite a bit, like, oh, I just cut and paste, oh, this works fine. Yeah. So that's really what. The other one, embedding secrets in scripts. So this is also not good, right? Like, I mean, like file access or SQL Server, connection strings and so on. So that's why we had the implied auth stuff so that you can just do trusted connection and it just works, right? And then data transformations that can be achieved in SQL. So this is very important. So I didn't touch on this whole feature engineering aspect of what this whole data science or the machine learning process, right? So this is basically the state where like you look at the data, generate computations like some aggregations and do joins and so on. So these things are meant for SQL Server, right? So you really, I mean, sometimes like you will see a lot of transformations in these scripts which should be in the database, or it should be as part of your ETL, for example, right? So that's something, and we talked about batch mode, right? So with batch mode, you get even more higher perf because there are many functions in SQL Server, like window functions, which can run in batch mode. So that means you get even more perf. Access network resources. This is actually very important. You don't want to call a stored procedure in SQL Server and that thing just tries to, download some file from some FTP link or call into a web service, right? One, many SQL Server machines are behind firewall, right? I mean, you're not going to be able to reach anywhere. And then the setup in SQL also by default blocks all of this. So, I mean, it's not really useful. So don't do that. Same way with files. I mean, you want to avoid I/O in general on the database server, right? Like other than the SQL part. So now having all these files, reading files, or trying to read files from shares, I mean, it's not going to work out of the box. Same thing. So we secure the runtimes on the SQL Server box, so they cannot do any outbound network access, even file paths, like it's all ACLed, so you only get certain directories. So that's something to keep in mind. And this is a minor thing, but still, yeah, don't embed these calls in your app itself, right? Then you will have the same problem. If you have to revise something or do a bug fix, you now have to change your app, right? What are the do's? Well, first one I just put there just for, yeah. So we have a bunch of open source tools, and also like Visual Studio itself has integration. So you can run a lot of these, and like our tools for Visual Studio has ways to create the stored procedure definition itself in SQL Server, right? So you don't have to type it in. So there are capabilities there which you can leverage. SQL compute context. So this is basically pushing the compute over to SQL Server for the RX functions and not moving the data, right? So that's something to leverage. And then this we kind of talked about it. Data integration, this is also important. Like try to use the SQL features to get the data to what shape you want and where it should be, right? Like it can even talk to Hadoop and get some data from there, right? SQL Server. And then this is another important aspect, like how do you manage models? Like what version of the model are you running? When was it created, right? What features does it have? So now you can actually store that in the database itself, right? I mean, you have tables. I mean, you can define some schema and put it there. So that's pretty much it. So it's like, yeah, leverage the best of the both worlds. I mean, try to do stuff in T-SQL, which SQL is meant for. Use R and Python for what it can do, right? Okay. So I have a few scenarios which we'll kind of look at. So this one is about product review, right? So the scenario is I have a bunch of products and some reviews. So I want to look through those text and find out which ones are positive and negative and so on, right? So that's really so the input is like a table with products and then a review and a tag which says, hey, it's a good review, or it could be a rating, like a scale, like from 1 to 5, right? And then now you're going to build a model which is going to look at this text data and the tag and figure out what is the correlation, right? So if somebody says, hey, this is a good product, I mean, it's good, or like it's bad, it's bad. Like that's like the most obvious example, like in English, right? So there are algorithms which can actually do the language kind of analysis, right? SQL Server also has full text, right, which does the same thing, right? So similar way. So we'll build a model which can do that, and then at the end you can do some prediction, right? So let's go to, where do I have this? 6. Move to see it, okay. So in fact, we saw the script here, this one, which earlier. So this is the script which can do that, right? But let's look at the stored procedure version. So it's this guy. So there is actually, how many of you are familiar with the TPC benchmarks? Okay, like 5, 6 people. So yeah, there is an industry benchmark for database workloads, right? Like transactional workloads, analytic workloads. So now there is a new benchmark there called Big Bench. So the idea is how do you integrate or provide a benchmark which does both SQL and machine learning queries. So this is actually implemented from that. So it's one of those queries like the Q28. So that's about like using machine learning to do this review classification. So that's what you're seeing here. Okay, so let's maybe look at the data here. And this is something which is common in the machine learning world is like, hey, how do I split the data, right? Like it's like 80-20, 90-10. I mean, like this is how you split the data. So meaning like you use 80% for training and then the rest of the 20% to do the testing or the evaluation of the model, right? because a lot of times you may have to actually run through multiple models. You may have to tweak certain parameters and see which one is good, right? Because you don't want a model which is 100% telling the truth, right? I mean, that means either the data is kind of wrong, it's not a representative sample, or the model is not producing the right results. So usually you want something where there is some variability. So yeah, so this is how the data looks. It's a very simple table with the key, the content, and then a tag column. Tag is like in Amazon, right? Like you see these stars, like 3 or 4, whatever it is. So here we're going to use this library called Microsoft ML, so Microsoft Machine Learning one. So like I said, Microsoft has a huge investment in machine learning internally, like Bing, Xbox, SQL Server. I mean, we all use machine learning in some form or another. How many of you use Azure SQL DB here? Okay, like about 20. So there we have a portal, we have a feature called Automatic Index Tuning Advisor, right? So that one actually uses some machine learning information to suggest which indexes can be created. So there we actually mine statistics from hundreds and thousands of databases and then build these models which can actually tell you, hey, if I create this index, your perf will improve by X%, right? So that's an application. So this Microsoft ML has a bunch of algorithms which internally Microsoft, we use it in many places, and it has one algorithm which is this logistic regression, right? Let's quickly look at what it is this guy here. So you can think of it as in the machine learning world, there is like algorithms which can do like classification or like a multi-class kind of thing. So it's one of those. And in this case, this has built-in models for many languages. So it understands which words are noise words. Noise words are words like a, I, in, because it doesn't really add any meaning to the sentence or the information itself, right? Those are considered noise words. Or a number or a word like 1A or something, right? I mean, it probably says where the bullet is, but other than that, there is no other information. So it can actually prune all of that, remove that, so that only the relevant information is there in the text, right? So it's got a bunch of these parameters which can do all of this. Similarly, punctuations, that's another thing which is important, right? Like certain languages. So it takes all of this information, and then the relevant piece is this one. So if you're familiar with R, this is called a formula. So the left-hand side is typically the column or the attribute you want to predict. So in the result, you saw the tag column, right? This guy. So that means the model is going to learn what in the content results in the tag being a 3 or a 2 or a 1, right? So that's what it's going to learn. So the right-hand side in this example is just the content column. But in I'll show you later other examples where it could be 20 columns, 30 columns, thousands of columns, right? So those are called typically like features. So then the other obvious parameter is, hey, what is the data I want to use? And the rest of this stuff is really parameters to tune the particular algorithm, right? Some I touched on, like the stop words, whether you want to keep numbers and so on. And then the other thing we'll do is we'll take the model, once it's produced, we can now store it in the database, right? So you serialize it. I mean, there's one way to serialize an R. Same thing, I'll show you the Python code also. And then you can return the model to SQL Server, and it stores it in a table. And then, this piece of code is showing how you can actually store it in a table in SQL Server with some other information, right? Like, how long did it take to generate the model? How long did the entire process take from query execution to building the model? Because this is all very important statistics you want to track, right? Like later, say, today you have 1 year worth of data, and tomorrow you want to analyze 2 years. Okay, how do I predict like what is the perf difference going to be? And I also want to track the performance difference, right? So these are things you could do with SQL Server, right? So that was the training part. And then we'll use the same library, and then we'll do the prediction. And like I said, in this case, we'll use like 20% of the remaining data. Right? So that's it. So this one, we can quickly run it. It takes about a minute, but don't have to wait for that to run. And let me go here. Yeah, so same thing you saw here, right? So you can actually run, so it's pretty much the same code. You can either run it from R or, so this is usually the data scientist will start here, right? I mean, that's where they will, because it's easier to debug here. And also a lot of times you want to visualize the data, right? I mean, those are things you would do here. You're not going to do that in SSMS. So that's why, I mean, the code is pretty much the same. Then you take the thing and you can run it here. It's going to take time. Okay, so let's go to the, oh, finished. And then at the end, it prints some accuracy, like, I think it's like about 80% or something, yeah. That is the accuracy of this model. So that means 82% of the time it can predict the right thing. So given a review, it can say if it is a good or a bad one, 82% of the time. So that's what that means. And then you can actually go and see, run a query and see. So you see all these scores, that's the probability. The score.1 is the first rating, score.2 is the probability for the second rating, and so on. So in this test data, you can see that for one row, like there is 2, and then the model actually predicted it's a 3. So I mean, there'll be other rows here like that, like where it's 1 and 2 or something. It's hard to see. Yeah. Okay. Let's go to 5. What else? So that was the product review. Again, the same thing, information could be tweets, right? Or you have a GitHub repo where you publish some sample for your customers or whatever, right? Or you have your own, project, and there are a lot of comments, and you can take those comments, put in a database, and do some kind of analysis like this, and it can come back and tell you, hey, it's a positive thing or a negative thing, and so on, right? So those are ways to leverage these things. Okay, so the other example we're going to look at is what is called campaign optimization. So this scenario is like you have a bunch of leads and various channels of contacting customers. So it could be either like sending emails to them, giving them a call, or sending them a text message, and so on. So what we want to actually do is look at all of these campaign leads and data, and then recommend what channel you should use, right? So this is again based on historical information like conversion rates. So you had a product release and you did bunch of campaigns, like it could be flyers, it could be like text message, whatever, email bulletins, whatever it is. So now based on that you get some conversion information and then you store it, and then now you want to actually go and train a model which understands, okay, which information from the campaign data resulted in conversion. So there it will take input like demographics, right? Like who did you send the email to, right? What time of the day, do they work? I mean, how much income do they make, and so on, right? All of this could be input to the model. And then, yeah, you want to predict like, okay, what is the best channel to use, right? So this is more usually like a business user. Now they are in a dashboard, and then you are exposing all of these predictions, and then they can actually, when they are designing new campaigns, they can go look at this dashboard and say, okay, maybe for this I should actually do email. And also I should send it on a Wednesday and not a Monday, because people are flooded with catching up on emails from weekend. So those are things which we could expose. Let's look at how you actually do that, right? Okay, so back here, this guy. So let's quickly look at the data. Actually, it's running a query in SQL, but yeah. So this conversion flag is the one which is of interest in this case. Like 1 means there was a conversion, meaning like it could be either people signing up for a credit card or whatever, or it could be somebody signed up for your beta of a program, whatever it is, right? And then the rest of all is the information which you have about that particular customer or lead, right? Like what is their age, credit score, I don't know why, but yeah, state, like which state, how many dependents. I mean, this is very common, like if you've done some of these surveys, sometimes they'll ask all of this information, right? So you collect it and then you mine the information. That's really what. So it's got all of these. So now what we can do is you can do a training on the thing. I mean, it's going to look almost like the same code. See where you define this SQL Server data, which is basically a query, and then what you want to do with it, right? And then here there are, I mean, this example shows two things. Again, all of these are available in GitHub. I have a link later, so you can go play with it. Mine is optimized. The one in GitHub, we'll have to fix it. But okay, so this one we are going to use what is called a random forest algorithm. So the forest you can imagine as like, so you saw all these 20, 30 attributes, right? So it actually creates like kind of links which result in a conversion. So that means like, say for example, somebody who's like 40 years making, I don't know, 100,000 salary and blah, 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 did the conversion, right? So it finds out that path. So that's what the forest, right? Imagine a forest with a bunch of trees. So that's what it's actually building literally. So in this case, it's building 40 trees. And the forest represents all of these attributes and conversions. And it's going to take all that column as input. Like, I mean, you can see like age, income bucket, credit score, ethnicity, blah, blah, blah. And then there are other interesting attributes which we compute in SQL Server, like how many text message counts, how many email counts, what was the previous channel which was successful, and so on. So that's all information to the model. And then it's going to spit out an object which understands, based on this data, what the conversion was, right? That's really what it is.
So it knows
Yeah. So the input to this is this whatever data you saw here. It's the same query, this guy here. Yeah. So the mapping is the column names and the formula is basically one-to-one, right? I mean, it says plus in R, but the notation it's not really addition or anything, right? It's not that. The formula, that is how you represent in R. Okay, so this basically that's what it's doing, and then another example. There are many ways. Just like in SQL Server, there are probably, I don't know, 10 different ways of creating a temporary table or something, and same thing. There are many random forest and decision tree algorithms, and this is another one. It's called a boosted tree, right? So that's what it's called, B trees. Not like the SQL B tree, but it's a similar one. It's a boosted tree. So now same thing, you can actually run this, and then so here I have some numbers on how long it takes. So on my laptop, this thing, it has about 80,000 rows, I think, yeah. It runs in about like, I don't know, 1 minute and 44. On this big server, it runs in like 57 seconds, right? And then you can later go look at the models. I mean, I already ran it, so I'll just show you what, oops. I mean, the model size, I mean, I told you it's like a blob, right? It's just an object. So it just shows like how big the model is. Like the random forest one is like about 6 meg. So sometimes these models can be huge because imagine like you have thousands of columns and data. It has to compute like statistics, just like SQL Server, like, you know, histograms for index statistics. So same thing, some of these can be huge. Now you can store all of these very efficiently in SQL, right? So it's that is a good part. Okay, so then same thing you can, I mean, we talked about like how do you evaluate performance of a model, right? You don't want a model which is always accurate, and you don't want a model which never predicts anything too. So it's somewhere in the middle. So that is usually termed as like accuracy, or like there are many ways to look at that thing. And one way is what is called like ROC curve, right? So it says like, okay, how the model is performing based on the data. So this is some piece of code which actually shows that. Did it finish? Yeah. So it's about 50 seconds. So you can actually now run all of this in SQL Server, and then I won't run this. It can spit out like, hey, what is the best model which was, based on this information. It thinks, right? So it can say, hey, use this random forest model. Or again, all of this could be operationalized, right? This decision. Let me show the Python code also here. Some of this won't work in CTP2. I mean, this function, the RX deforest. This is the same function, the equivalent one in Python. But yeah, so this is how the code looks. So this is basically Python code, but the interfaces are pretty much the same. You define a SQL Server data. I mean, here I have some column information defined, but that will go away in the future builds. Okay, so now how do I expose this in the thing, right? Like, so here is an example of how you would see it, right? Like, this is a Power BI dashboard, which is taking the final predictions and then putting it in some table, and now you just expose it, right? So imagine I'm a business worker, and then I can come here and then, oh, okay, for this particular campaign, okay, what is the model recommending, right? It's saying to do a cold call. I don't know what cold call is. Cold call is just, I think, calling some random number, I think. So cold call on a morning, Tuesday morning, and it says the conversion could be about 78%. So, okay, so then, okay, fine, maybe you should do that, right? Same way, it can say which one is really bad, right? Like, for this, I don't know, together we are stronger, I don't know what so for that, apparently, yeah, it's like only 0.04%, so, I mean 4%, that's bad. So this is information which now, all this intelligence, you can now expose it very easily, right? Because it's there in SQL Server, it can, I mean, any app, like you can even put Excel on top of data in SQL Server, right? So that's what it is. Okay, let's look at what we have later. So that was campaign optimization. So this is something we are adding in 2017, what we call native scoring. So now you saw all that workflow, right? So the scoring part is typically the part where the performance requirements are very high, right? Like meaning there it's usually one row kind of thing. Like in the fraud detection, you want to actually score transaction as it's being inserted into the database, right? So that means you want to do it in like few milliseconds, right? If you use the current infrastructure to call R or Python, I mean, it takes about like 100 milliseconds to start a process in Windows, right? So that's the overhead. Like if I just go to command prompt and just start a process like rterm.exe, it's going to take 100 milliseconds. So now we want to avoid all that. So what we did was we took the Microsoft R server, which is Microsoft's code. So we took that scoring stuff and we expose it in SQL Server as a native function, right? I'll show you how it works. So this scenario is like credit card transaction, same information. The input is typically some set of features. In this case, like what is the risk factor for certain IP addresses and so on, demographic information. Similarly, did the customer do a lot of big purchases in the last 30 days? In the last 24 days, what was his credit card activity and so on, right? So those are all input, and then we'll train a model, and then same thing, we'll predict now using a SQL query, right? Go back here. I can't read. Okay. What is the training one? Oh, this guy. Okay. Yeah, here we go. So let's first look at this data. And it's actually a complex query. So look, I mean, you can look at this query, right? So it's looking at some sample data, and it's doing a whole bunch of joins, and it's also doing some computations here. So, okay. So this is what the data is, right? So you have transactions, and you have all of these attributes. And then there is a column here called label. I think it's somewhere at the end. I don't know where it is. Yeah, this guy, label here. So this has a bunch of zeros and ones, so that says which one is a fraud. So this is again historical information which you have, right? So now the model is going to take all of this data and then produce some object, right? We can run this here. I mean, it's on this machine. It's pretty fast. So here also we are going to use this same algorithm which you saw earlier, boosted tree, right? So again, many of these algorithms can be used for different purpose. So same thing here, it's going to basically flag a transaction as a fraud or not, right? So same algorithm, you can use it. So yeah, so it looked at, I don't know, 10,000 rows here. So same way, let's look at what is the model. Oops, I should have maybe run this. Oh, it's going over the VPN, getting my, I have a lot of models there. I don't think I want that. Okay, anyway, it came back. So it's just to give you an idea of what is the size of the model and so on. So now, here I want to show you one of the new things which we add, right? So this is the line. So now for the native scoring, what we have is now you can take the model and then serialize in this format, which is used for what we call real-time scoring. So you take this model. So this is now serialized in a different format, which SQL Server can understand, right? And it's also like more compressed and so on. So that's the size difference here. You can, yeah, like, so this is about, for this guy, like it's like 127K or something, right? So now how do you use this for predictions? So what we did was we added a new function, this table valued function called predict, right? So now it's just a SQL query. So now there is no R code, Python, none of this running here. So you give it a model and then you give it some data. In this case, I have some table. Actually, this guy here is a TVF. It's going to, I mean, it's doing a bunch of joins and yeah, it's like a big table. So you can get the data from that and run a SQL query, right? That's it. So it actually looked at, I don't know, 10,000 rows in this one. And then it predicted like, I don't know, one fraud or something, right? So this is the new function which we're adding here. And you can actually run the same thing on Linux, right? So same SQL query, I'll print you. I think it's in Ubuntu or something. Yeah, there you go. Since it's just a SQL function, there is no, I mean, dependency on the other things. So you can just run it on SQL, on Linux too. And we are actually working on getting it in SQL DB also. So that was the demo for the scoring part. Okay, cool. So last slide I had was just, yeah, what are things we are working on, just to give you an idea of where we're kind of going with this, right? There are a lot of problems to solve here, and this is what we're kind of looking at. Predict function, I showed you that. The other one, which is also important, is this whole package management, right? Like, so you have all these libraries, and if I have an always-on cluster with 4 nodes, I have to go install the package in every node today, right? So we want to make it easier. So we are going to add this in-database package management capability, which just like CLR assemblies, you can store it in the database, and then the SQL Server engine will automatically, install the package for you. So that's something we need for even Azure SQL DB, because there you do not have control over the environment, correct? And then the rest of the things, yeah, we are working on is, getting this working in SQL DB itself, so that whatever you're running on-prem today, you can run it in our managed environment. And then enabling it on Linux. I mean, it won't be there in 2017, but that's something we're working on. That's pretty much what I had. So these are the resources. We have links to GitHubs and then getting started tutorials for both ML and general developer stuff. This is the talk. I think the 180, I think it's here probably. I don't know. So these are the sessions. And we are in a SQL, what is it, machine learning booth, I think, yeah. So we'll be there. So feel free to stop by. Any questions? So that's my email address. So if you have trying to implement or do something with this, I mean, feel free to reach out to me. We work with a lot of customers, and we'll be happy to help you out and get any feedback. So any questions? Yeah.
I just wonder what's the relationship between the SQL Server, the extension framework you just reviewed, and the existing SQL CLR functionality?
Oh, okay. So the CLR one is in process, right? So that
Yes.
actually runs within the SQL Server address space. So this is running outside. And this is also a little bit loosely coupled than CLR.
Okay.
So this is more focused on the data movement and the analytics part. So here, all of these scenarios, you spend more cycles on the, not on the data part, like you spend more on how do you build the model, like that aspect.
Yes.
So this is focused on also integrating runtimes, which Microsoft doesn't know, right? So we want this to be able to run like in the future, like Go or something, or
Right.
Java, right? I mean, today we have R and Python. So that our thinking is like then in the future, if some new language comes and people are using it, like, I mean, okay, here is the framework, you integrate it, right?
So the advantage is the efficiency of the data pipeline, and you're out of process.
Correct. I mean, but here we are still efficient. Even so, memory copy within 2 processes on the same machine is, I mean, we can move like terabytes, like very fast, right? So that's not a problem. And then some of these algorithms can run in parallel, so you get like even more. Even if you have a lot of data to scan, I mean, it can compute on the fly.
Okay. Thank you.
Any other question?
Yes. So are due to
Yeah. Oh, you want? Oh, yes. Oh yeah, there was someone else's question. Oh yeah.
Yeah, so R due to lexical scoping basically requires to load the data in memory when you do the model. Let's say you calculate the model, you create the model. So let's assume I have dedicated like 10 gigabytes of RAM for, let's say, this process, but actually I have like maybe terabyte or petabyte of data. So how this situation will progress then?
So
Will it work or will it not?
Yeah, no. So the Microsoft R server ones and the Microsoft ML ones, they don't have the limitation of the data like need to fit in memory. So that's the benefit, right? So if you download some open source R function, like I don't know, like LM or FastLM or one of these things, then you give it a data frame. I mean, it has to fit in memory. So this is where the difference is. Like, so if you use the ones which we ship and the algorithms which we have, then you don't have the size of data restriction. So then you can crunch through a terabyte fine. So that's the difference. Like, so the algorithms which come with the part of the Microsoft R server is
So all
can
of
handle
the RX
yeah, anything with the RX stuff can handle.
basically can
yeah.
stream.
Yeah, it can stream. It can do parallel computation of the model and so on.
Okay, thanks.
Yeah, the security context is, oh yeah. Oops, it runs on local user accounts. Yeah, it's like we create user accounts on the SQL Server machine. Yeah. Windows user accounts. Yeah, sure.
Are there model training DMVs and system tables available in SQL Server?
Well, I didn't get the question. What?
Are there model training like DMVs, system tables available?
Oh, you mean for this?
Yeah.
Oh, yeah, there are.
Like for the history tracking that you showed and stuff like that? Or is that it was all?
Yeah. Oh, thanks. Yes, there are a lot of DM. Like, for example, you can find out which query in SQL Server is using what R process and so on.
Okay.
Similarly, there are DMVs, like the resource pool exposes a lot of statistic information, like how much CPU was used. So there are reports which actually give you that.
Okay.
And then we also use a primitive in Windows called job object. So Windows itself has a lot of performance counters. So you can actually just monitor that and it will show you like all of this.
Okay.
So yeah, it's fully.
Okay. Thank you.
Does
Cool. Oh, yeah.
can SQL can it use GPUs to accelerate the training?
Yes. So the Microsoft ML has like neural net and few other algorithms which can actually use GPU. But most server class hardware today doesn't have GPU.
Right.
I think the newer ones they do, but in Azure, for example, you can get a VM with GPU.
So in Azure, if you're using SQLDB with this, you could have it go out and do it on a bunch of GPU servers?
No, SQLDB will be different, right? That's that's our nodes. It doesn't. Again, you don't want to remote anything. All of these calls. Then you have the same problem, moving the data over to that machine, right? But what I meant is like Azure has VMs which have GPUs.
Okay.
So if you're running on-prem like SQL Server 2016 or 17, you could run that. That's what folks do.
Okay.
Because there the difference is huge, like for some of these algorithms.
And is that something you have to do a lot to configure, or is that something it just knows there's GPUs and uses them?
No, it's depending on the library, it will be as simple as, hey, I want to set my context for this neural net computation to use GPU or something, and then how many threads or some simple parameters.
Okay.
Yeah.
Thanks.
Cool. Yep.
I have a theoretical question. I apologize if it's maybe too basic, but for all those different machine learning algorithms that you've shown, how do you find out which set of attributes you have to provide for that, each given algorithm to function effectively?
Okay. So it depends on the model. Like, so for example, if you're building this linear regression model, when you look at an output, like if you do print of the model, it will actually, the algorithms are intelligent enough to drop variables which is not needed. Like for example, you have a column which says, I don't know, or you have data which is like all males. And then somewhere, in the, I mean, if it's all ones, it's going to say, okay, this is not adding any relevancy to the information, and it will actually drop the information. And then there are other ways, like for example, they'll say like errors and coefficients, which they'll expose, like values, and using that you can determine. So this is the data science part, where you have to look at the model. Depending on the type of model, the information could be different, and you figure out which one to remove. Some models will just drop it automatically, so you don't actually have to do anything.
So if I have an entity with like, thousands of attributes, how do I come up with an initial set of attributes that I have to kind of provide?
You mean which columns to use?
Yeah.
Yeah, well, that is again, that goes back to usually a business user. Like we are working with this credit union, and usually the business side is for the folks. Like in this example, how do you predict like loan defaults, right? So the business person will actually know like how customers, get new loans, what kind of customers are defaulting. Some of this could be very regional stuff. So those are the guys who actually come up with which features you need to use.
So there is some domain-specific knowledge.
Yeah, definitely. This is a lot of domain. It's no different than writing a bunch of SQL reports, right, on some data warehouse information. Some of that requires domain information. But there are other algorithms like this clustering algorithm for classification, which doesn't need domain. Like you can just give it like a huge data set and say, hey, give me the groups of things which look same or like which feel the same. And it will just tell you, right? But then you need to go and understand like why did it group these things together, kind of. So
okay,
it depends, yeah. Cool.
So R is supported in 2016 and onwards, but the data can be in the older DB.
Oh yeah, definitely, yeah. You can either have the 2016 thing talk to the older database, or I mean, I would probably suggest like just replicating the table or something to your 2016 and then just do it there.
What's the algorithm for time series? Do you know?
Depends. Like there is like Arima, there is like Forecast from I guess Facebook or Twitter. No, Forecast is from Facebook. Yeah. So there are like the public R packages which are popular. The Microsoft R server ones currently doesn't have the time series one, but that's something we're looking at.
Okay. And one more thing, how to get to this? Is there any place where we can get the slides? Because the links we have to.
Yeah, this should have been uploaded. I uploaded in the morning. You should have the slide deck also. Yeah. Yeah, I don't know when they give it.
In channel 9 or somewhere.
Yeah, build site itself. You should be able to download everything.
I see. Okay. Thank you so much.
Cool. Any more questions? Cool. Oh,
so just to circle back, so it doesn't sound like there's any inside that Microsoft ML library. It doesn't have any of the the dimension reduction algorithms implemented.
Well, what algorithms?
Like ridge regression or anything like that, where it.
No, it has regression algorithms.
Well, ridge like lasso.
Oh,
where
okay.
It'll zero out some of the features so that you can identify. which ones?
Yeah,
No. Or is it, so that would be more data pre-processing. You'd do that on your own machine and figure out all of that. And then,
okay.
right on.
Yeah, I mean, like like SVM is there. There are a few other algorithms like neural net, and it depends. Like, I mean, we look at the customer feedback and then figure out like there are literally hundreds and thousands of algorithms and implementation. Even linear regression itself, like there is so many. There are things with outlier detection. There is like a way to do fast linear. There is like slow. I mean, like generalized regression models. I mean, it's like that space is like this is the process of data science where you need to figure out which ones to use.